So Python 2 is all about dictionaries and regex. So let's get into it. So firstly, I just want to quickly review a couple of data structures that you should be aware of by now. So the first one is a list or an array. So they are very similar. So I just group them together in this situation. So in this case, we have a list with colors. So we have red, blue, green, black, and pink. And each of them in their little box have a specific position. So if we count from the front, we start at 0. 1, 2, 3, 4. But if we start at the back, it's -1, -2, etc. So why is this useful? Okay, so this is the list name, the forward index, the list element, and the backwards index. So if we ask for color list square bracket 2, it would retrieve the value at 2, which is green. So we'll get back to the minus index in a little bit. But basically, if we ask for -2, we would receive black. Okay. So strings, that's the next type that you should be aware of. So strings are basically just a list. So if we have the word hello world here, it's basically H0, E is 1, etc. The space is also a value on its own, which is 5 in this case, and then we end at 10. So the length of the string is 10. Okay, so we have an index and we have the string value. So if we ask for str, this is the string, value 2, we will receive the L. Okay, so there's a couple of functions that is in Python specifically to enable you to use lists and strings. So the first one is .index with a value. This returns the value of what is at that specific index. So similar to what we did now. Then a append value. So if you want to add something on. So if we took our color list and we wanted to add maroon, we would use append. Then there's an insert. So if you want to add at a specific place, so let's say at location 3, you want to add a different color, you can use insert. There's also remove, a sort functionality, a sort descending, and a sort all the values according to lowercase. So in this situation, you would ignore uppercase and lowercase. It would just treat everything the same. Okay, so list hello. So this is a string. This will produce the following. So then you can see this list, you can convert a string value into a list more explicitly. Okay, so slicing. So I spoke a little bit about slicing last week. So basically we have the string, which is the string that was converted into a list in this case, which is called string. We want to get the values from 0 to 3. So here you have the colon that tells us from this position to this position. So HELO we will receive. So here it is from position 3 onwards. So in this case, so it's remember 0, 1, 2, and then 3, 4. So from 3 onwards, then you'll get LO. In this case, so it's from 3 forward. The next one, this is 3 forward. You'll get HEL, sorry. And then string -1. Remember, -1 starts at the back is -1, so that returns 0. 800. Okay. So then the next type of data structure that's quite interesting in Python is called a dictionary. So this is basically a key value pair. So in this case, we have a key, which is user1, and it has a value Mike. And then another key, another value, etc. So it's very much, you always have this structure of a key with a value. The value can be a bit more complex, but there's always a key associated with it. Okay, so if we have the following, we have a dictionary with brand, which is Ford, model, Mustang, the year 1964. and we want to say print this dictionary, what would our output be? The following output would look like this. So we have brand, Ford, model, Mustang, year 1964. So you can see you have the key and the value separated by a colon. Okay, and then the next pair, so key and a value, etc. Okay, so if we want the following, so we have the same dictionary, but now we ask for X equals this dictionary where model. So, and we need to print out X. What would we print out? If we print out Mustang, because it will go to the key, which is model, and it will get us that value, which is Mustang. Okay, so in this case, there's just another example. If model is in this case, we check if the key model is present in the dictionary. If it is, we print out that model is in this dictionary. Okay. So when would you use a dictionary? So a dictionary is a bit of a strange type of data structure, but there is a couple of uses for it. So for example, if we have a person, we can have the information as a dictionary. So name Jack, surname Ripper, age 26. Or we can have cell phone brands. So Apple as a place with the key 0, Samsung 1, Huawei 2, etc. So it's when you have a relatively fixed list that you will refer to quite a bit, a dictionary can come in useful. Okay. So next topic. So if we say you have a list of names and you need to extract all the names that start with a J, and there's also all the middle names as well. So I'm sure you can think of a relatively easy solution for this, but let's make it a bit more complicated. So you have a bunch of files in a folder, and you want to extract everything where there is a sequence 154 in the name as well as shapefile. So again, probably an easy enough solution, but let's see about a different way of doing this. So you can have a look at the last one, but you can see that this is a bit of a condition, and you need to extract information based on this condition. So for all this, you can actually use something called regular expressions. So this denotes a type of a string pattern. So it does a bit of a pattern matching. Okay, so what is regular expressions? So it's called RegEx or RegXP, which is a bit of a text matching where you look at certain patterns. And you can find this in basically any language. We're going to now focus on specifically how to do this in Python. Okay. So basically it's a more advanced way of doing a wildcard. So I think from SQL you're all aware of wildcards. This is just now another way of doing this, but a bit with a bit more flexibility as well. So basically, if you look at a search on a web page, for example, for web, this now gives us a bit more advanced ways of finding only the words that are linked to what we are looking for. Okay, so regular expressions is basically a language of their own. You can look at this here at the bottom. You can see it is normal alphanumeric numbers, but when you first look at it, it is a little bit strange. So if I were to ask you, what do you think this bottom thing does? I'll give you a second to think. You can see there's some numbers and letters with an at, numbers and letters, and again 2 to 63. So this is actually a regex for validating email addresses. So to make sure that there is something at something dot something. So this is just to make sure that your email addresses are actually correct. Okay, why would you use regular expressions? Input validation. So the example we showed previously with the email validation, that's a very good example of when you would use a regex. So find and replace. So if you are looking for only certain parts, not all words, things like that. Pattern matching in large text. So if you're looking for certain things when you have over 1 million records, and then it's also useful to shorten your code. Okay, so let's look at this example. So validating the phone number. As I said, this is probably something for which you can quickly figure out a way of doing this with code. So in this case, we have is phone number, which receives text. It looks at the length, then it looks at the first three values. It again looks at the length, checks if something is there. If not, return false. If not, return false. So you can see there's a bunch of different things that it does. And this is not a very nice way of doing it, and it's also very computer intensive because there's a lot of processing that needs to happen. This all can be replaced by the following. So phone number regular expression, re regular expression dot compile. So here we define this regular expression. So we say it's a digit, a digit, a digit, separated by a hyphen in this case. So that's maybe the way we want it in our database, with another 3 digits separated by a hyphen followed by 4 digits. So now if we have a bit of a string value and we want to identify only the cell phone numbers, pull them out, we can say that phone number regex dot search with our string value, and this will pull out this value for us. So if you have a bunch of text and you want only phone numbers pulled out, this is a great way of doing that for you. Okay, so a bit of a quick guide to regular expressions. So you can see there's match in the beginning of the line, the end of the line, any character, white spaces, non-white spaces, repeating values from 0 to more than one times but not greedy, etc., etc., etc. So this is definitely not something that you're going to learn out of your head very easily. Generally, there's a bunch of websites where you can find a couple of these regular expressions, and you would use that in a pinch. Okay, so regex in Python, there's a library called RE, regular expression, that you would need. So every time you use a library, as you probably saw in last week's notes, you would say import RE. Then we can use re.search. If you have text and you want to find that specific piece of text within it, then there's also other functions such as find all, which extracts a portion of the string that that matches your regular expression. And you can also do some slicing, such as from 5 to 10, things like that. Okay, so how do we actually write a good regular expression? So you need to define the scenario. Use natural language just to describe what is it that you're actually looking for. Thereafter, you can come up with a plan of breaking it down into these specific characters that is required. Then you can start testing it using these like real-time testing environments such as regex 101 or regexr.com. So these are nice places where you can add some text, write a regular expression, and actually see if it would work. Okay, so some examples. Okay, so the regular expression for identifying an email address is basically recipient name followed by an @ by the main part of the name, domain name, followed by the top level of the domain. So that is basically, if you break an email address up, that is what is present. So if we look at this again, what we saw at the beginning, so we have the recipient name followed by the @ symbol. So followed by the @ symbol, the main part of the domain, followed by the dot, and then the top part of the domain. So there's usually no numeric characters in this part. So that's why it's limited to only alphabetic numbers. Okay, so if we look at validating a password, we can, for example, say our length of our password needs to be 6 to 12 characters long. There must be at least one uppercase letter. There must be at least one lowercase letter and at least one digit. So what would the regular expression for this look like? So again, we can say we start at the beginning. it must have at least one lowercase value. So one or more lowercase values, one or more uppercase values, one or more digits, and it needs to be 6 to 12 characters long. So another example, you can have a look at it here specifically on this website. I'll put a PDF also in the folder for you. So we have a bunch of names, universities when they left, and then there basically their salary. So we want to basically extract the following. We want the name of the president, the name of the college, as well as their salaries. So to do this, you can always go and write something that goes according to the commas and the semicolons, but you can do it much easier with regular expressions. So to create a pattern, we can create our pattern and we say that it is everything until we get to the comma. So the first comma. So it's names, and we stop at the first comma. So in this case, we say find the pattern, and we would extract all these names into a list. Okay. So then we can create another list by using the salary. So again, we create something. We say from the dollar sign until the next um, the next the comma after semicolon. We extract the values again to get our salaries. So then in the end, we can actually create a little table like this with all these values. So now it is much easier to handle. We can much easier query it and so on. Okay. So this is just a bit of an overview of regular expressions. Probably it might be in the assignment, but not necessarily in the exam. But yes, we will discuss that closer to the time. Thank you.